Hey, welcome back to Math with Patrick. Today's June 29th, and we're solving problem number 180 from the Daily Epsilon calendar. And it looks like today we have a pretty standard system of equations. This right here is a line in standard form. So if I graphed it, like if I typed it into Desmos or something, I'd get a straight line. Same thing with the second one. There's going to be probably just one spot where the x and the y values satisfy both equations at the same time. And judging by today's date, that's when x is 29 and y is something else, maybe 5. I just did a little bit of quick math in my head. I was like, if this is 290, then adding the 20 means y is 5. But that's a little secret. We're not supposed to really know that x is 29 right now. Let's try to solve it, maybe using 3 different ways. There's 3 main ways to solve systems of linear equations, and the first is called elimination. That's where you try to multiply maybe one or both of your equations by some constants so that you line up the coefficients, so these numbers, of either your x value or your y value. I notice that 4 and 12 are pretty similar to each other, and I'm going to multiply the top equation by 3. So the 10x turns into a 30x, the 4y turns into a 12y, and my number on the end turns into a 930. And the reason why I wanted to do this, again, was to match up the coefficients of one of my 2 variables, and it just so happened that y seemed like the easier one for me. The idea here is now I have 2 equations, and they're both balanced. So the left side here is equal to the right side here. Same thing for the other equation. So if I pile on all of this stuff together, it should be the same as piling all of this on each other as well. So I can add one equation to the other. And here I get 37x. The y's cancel out, or they're eliminated, hence the name elimination. And then I can add this together. It looks like I get 1073. So I just need to figure out how to divide 1073 by 37. Not the easiest, I'd say. Maybe I'll just do some long division for this one. I think 37 is going to go into 107 twice, and 2 times 37 is going to give me, is that 74, I think? Right, because 60 plus 14. Subtracting that away, I get 333. And I think that this one's going to be a 9. So let's just double check with some multiplication first. 9 times 7 is 63. 9 times 3 is 27. Add the 6, we do get exactly 333. So with no remainder, looks like the division does tell us that x is equal to 29 today. Cool. And then, I think y is equal to 5, although I found that out by just kind of doing some mental arithmetic with the first equation. So let's just double check that 29 comma 5 as our ordered pair does make sense for the second equation as well. 7 times 29. I could do maybe 30 times 7 a little bit more quickly. And then if I make that a 29, I'm going to subtract off 17. So it looks like I have 203 for 29 times 7. And then minus 12 times 5, that's going to be minus 60. And then yes, indeed, 203 minus 60 is 134. So I did find my solution through elimination, and it's always good to double check that the 2 values for x and y also work for both equations, rather. I was going to say the other equation, but it's important to check for both just in case. So that's how I'd solve it with elimination. We're all done, so feel free to, go enjoy the rest of your day. Though if you want to stick around, I also want to solve it 2 more ways. Let me clear some room for substitution. Substitution works by just isolating one of your 2 variables and then sticking it in the other equation. And for me, maybe it's easiest to, I'm trying to pick a variable to isolate. Since I'm solving for x today, I probably want to isolate y and then substitute out a y. Although the division here seems like it's going to be kind of hard, so maybe I'll isolate y in this equation. So I'll just start out with 10x plus 4y equals 310. And then I could divide everything by 4. And then so I get, I'll just write it as 5 halves x plus y is equal to whatever 310 divided by 4 is. I know that 100 divided by 4 is 25. And so this is going to be almost 75, or maybe a little bit above 75. And if I tack on 2 more 4s, that's going to make it a 77. And so my answer here should be 77 and a half, which I'll just write as a decimal here. Cool. So now that I have y by itself, let me just isolate it real quick. If 77.5 is a decimal, might as well call the other one a decimal too. And then now I have some kind of equation with y all by itself. And I got it by using this top equation. And so if I stick that information into the bottom equation, I should be able to solve for x. We're going to get 7x minus 12y, but instead of y, I'm going to write this new expression that I have for x, and this should be equal to 143. And now it's just a little bit of algebra and arithmetic to figure out that x is 29 again. How about let me double what's on the inside of the parentheses. I'm kind of borrowing a 2 from this 12, and I'll double that coefficient, and I'll double this constant. Let's see, 77.5 times 2. I could probably do that in my head. I think that's 145. No, it's a little bit more than that, isn't it? Because 70 plus 70 is 140, and then tack on the 2, 7.5. That is going to give me 155. This is still all equal to 143. Now let me just distribute the 6 again. So we get 7x. This right here gives me a plus 30x. Over here, I don't know what 155 times 6 is, so I guess I got to do that. Honestly, I do like the elimination strategy a little bit more because I feel like I just run into less arithmetic that way. And then finally, I'll combine my like terms. This right here is a 37x, and then adding the 930 over to the right, interestingly, actually, is this addition that I did already. So these two strategies of elimination and substitution kind of overlap. Like, I already used these two numbers. I already added them together. So it's kind of interesting, or maybe not surprising, that it's coming up again, because ultimately I am getting the same answer. So maybe along the way, I should get the same numbers. So that's the other algebraic, like pen and paper way to do it. And so finally, let's try solving it with graphing. And so there's the first equation, and the second one was, oh gosh, what was it again? 7x minus 12y equals 143. There we go. I tried memorizing the numbers and it turned out okay. So here are our two lines. They just kind of intersect in one spot. There's only one spot on the whole graph that they intersect. And it's right here when x is 29 and y is 5. So of the three methods, honestly, this one's my favorite just because it's a lot easier. You don't have to trudge through all the computation, though I think it's kind of nice to have multiple different ways to solve certain problems. So there it is. There's a 29, 3 different ways, and we're all done. I'll see you tomorrow, though. Okay, bye.